Today we are going to continue our discussion on the phases of machine learning. In the initial video, we learned about data transformation and EDA. How do we convert our tabular data into a good format which machine learning algorithms can learn? And the second phase we are going to discuss today is training the model. So we have prepared our data. Now we want to see which algorithm suits best for our use case and find out how is the accuracy and other parameters. So let's get into it. So first of all, our new data is diabetes data set, which is cleaned. So let us load that, and I will link the previous video somewhere here. Okay. So once we have loaded the data, the first thing we would do is split the test as well as the data and the actual output. Always the data is called X, or the features or the columns we are using to train is called X, and Y is the target. And in our case, the name of the column itself was target. Second interesting thing we will do is split our data set into two groups. And the size is around 20% we are splitting, right? So 80% of the data would be used to train, and the rest 20% would be used later to test if our model is doing good. So this is how our data set looks now. Around 736 rows are there for training, and 184 rows are there for testing. This is another interesting concept. Basically, because it's a tabular data and we are trying to draw a graph and others, it's always good to standardize the data so that we bring the data in a specific range, so that some features are not very high in value. For example, if you have a feature called age, it has a range of maybe 30 to 80, but there could be another feature which is any test result which could be from 1 to 2, right? So there's a difference in the range which makes the model confused, especially those linear models. That is why we do a scaling of the data. And to understand it a little better, we will try to see how the original age was. So this was the original 5 records of the age, the top 5. And after scaling, if you see, it converts it into a number between one range. So the age was between 20 and 83. After scaling, we put it between -2 and +2. So that's a small range, and most of the features will be inside this range. Okay. Now, the first machine learning algorithm we are trying is logistic regression. Logistic regression, again, there's another video explaining, going deep into logistic regression, but it's an algorithm which draws a S curve on the data set. This is the easiest algorithm to learn, and we will try to make our baseline with this algorithm. So if you can see, what here we are doing is we are telling it fit is where it tries to learn it, and later we are asking to predict with the test data set, the small data set which it hasn't seen before. And here itself it's able to provide a very good accuracy, 96%, almost 97%. That's a very good model. Ideal cases, this would be very good, right? And now, after we have tried with a linear model, let's also try with a tree-based model. These are the more advanced models, and they can even learn better and have a higher accuracy compared to the linear models. Same thing, we are importing random forest and doing a fit and later predict. If you can see here, it has 98% accuracy, and that's why the tree models are advanced and they learn a lot more. And another thing, if you see here, we use the scale data set because it was a linear model, right? Here we don't have to do that for decision trees, because at the end they create trees with conditions and they are not dependent on all the data set together. Okay. Now we found the accuracy, but there are other parameters also. So let us check on that too. So if you see, and we are trying to do for the random forest model, the precision also is good, the recall also is really good, and there is F score. All of them looks really good for this model, and each of these fields we will discuss more detail in a later video. But precision is the total number of positive predicted versus the total data set, right? But anyway, at the end we are seeing all of them are in the 98-97 range. Now let us also do that for our linear regression model. Here also, if you see, still the random forest has a better value. Even both the models are doing a great job. But in none of these parameters, linear regression has a advantage, right? So in those cases, we will always choose the random forest. Another interesting thing with these classic machine learning algorithms is they also tell us what they have learned. That is called the interpretability. So what here it is trying to say is, see, these are the features you used, and the blood fasting had the most impact on the decision. So just having blood sugar test, glucose test, and hemoglobin test, the percentage is almost 80% of its learning has come from these three features. So even if you drop some of the other columns which are down here, it won't affect the machine learning model much. Okay. Now what we are trying to do is, this is really interesting. We are trying to plot what this machine learning model has learned. So if you can see here, and if you zoom in, each of this decision tree, you can go and understand what is the condition it has. So this is the root node, and then it goes down. So if your new data comes, first it will check this root node condition, then it will decide whether to go here and here and like that, and that's how it decides. Okay, this is a tree based model. Similarly, for the logistic regression also, we can do a level of explanation, that is using this graph. So here if you say it's 0, that means they don't have much impact. But if you see, there are positive impacts, and in the similar way, the glucose test, fasting test, they have an impact. So if the values are high, then they have a impact on how the model predicts. Now finally we have created the model. Let's also store it. So we download it and save it, and let's say these are the models, right? They are usually stored as pickle files. Now I also want you to notice one more thing: the size of the model file, the actual executable or the output, raw output, right? In case of logistic regression, it's just 964 bytes. So it has such a small thing it has learned, the weight and the bias, but with that itself it is able to predict with 96% accuracy. But for a decision tree, it had to learn a lot of these details, right? So it's around 500 kilobytes. That also, in a way, it's a really small value, and in this example, I believe both the models have done a great job. And I hope you understood little more on the training part. We will come back on the final part of exposing this model as an API. Thank you.